As hyperscale clouds, cloud specialty providers and enterprise customers invest in next-generation compute and storage, along with an increase in the use of AI and ML clusters, they are fueling the need for data center networks to deliver higher and higher performance, increasing network throughput and doing it cost effectively. Almost 2 decades ago, the simple SFP optic replaced the GBIC and allowed the rapid deployment of 1 gig. When 10 gig systems and NICs became available with the SFP+, replacing systems, they provided a density improvement over legacy X2 and XFP optics, and a whole generation of compute moved from 1 gig to 10 gig using optics and passive copper cables, also known as DAC. At around the same time, the first 40 gig networks based on QSFP+ were being deployed, and leaf-spine networks had a healthy balance between downlinks to compute at 10 gig and uplinks at 40 gig. Since that time, over 10 years ago, a lot has happened in networking. 100 gig has emerged to become the de facto interconnect, and servers have moved from 10 gig to 25 gig. Both technologies based on a 25 gig NRZ link speed, leveraging both the SFP and the QSFP for cost-effective networking, based on system-on-chip packet processors that have scaled up as building blocks for mass market adoption of leaf and spine networks. Driving all this demand for more networking are rapid advances in distributed high performance and virtualized applications, combined with next generation compute systems that need higher and higher network performance with no loss of features or changes to the network architectures, and importantly preserve existing investments. We cannot disrupt as we innovate. The vast majority of enterprise networks remain at 100 gig and servers are connected at 25 gig. Enterprise networks are slowly starting to evolve to 400 gig as the switch interconnect, but cannot jettison the existing networks. The fundamental building block for the packet processor and the network interface has become a 50 gig PAM4 lane, but we are still a ways away from the average server needing 400 gig. The emergence of next generation network interface cards leveraging 50 gig PAM4 for 50 gig, 100 gig and 200 gig options is tied closely to the availability of switches with the right mix of interface speeds, port density, features, performance and efficiency. With the latest in the 7060X5 and 7050X4, Arista is introducing an expanded range of systems that deliver the long-term investment protection with support for up to 4 generations of server and network speeds that does not disrupt the status quo, provides a path to the next speed, and innovations around lossless communication, tested and verified with leading performance NICs based on PCIe Gen 4. The new 7050X4 systems based on the Broadcom Trident 4 provide expanded choices for leaf tiers without losing features and providing true investment protection. The latest 7050SX4 systems with SFP ports support interface speeds of 10 gig, 25 gig, 50 gig, and 100 gig, with an amazing 48 ports of 100 gig in a single 1RU system, ensuring broad compatibility for existing and emerging applications, and with 8 ports of 400 gig uplinks. The 2 new 7050CX4 systems with QSFP ports are optimized for dual 100 gig or 200 gig to each server, with up to 40 ports in a single system, and deliver broad support for interface speeds including 40 gig, 50 gig, 100 gig and 200 gig for both backward and forward compatibility. For enterprise networks, the new 7050CX4M provides 48 ports of 100 gig and 8 ports of 400 gig with integrated encryption support for seamless migration to 100 gig and 400 gig spine and leaf. While taking care of the needs of large enterprises with diverse server needs is the key to the 7050X4 series, we are taking equal care of the ever-changing needs of the clouds. With the new 25.6 terabit based 7060 X5 systems, bringing ever more choice to this range of hyperscale systems. Large-scale dedicated clusters and hyperscale cloud networks have been moving from 100 gig to 400 gig, leveraging a wide choice of both fixed and modular leaf and spine systems. For these customers, leveraging 800 gig optics increases network efficiency and lowers the cost per bit with a consistent approach that does not disrupt operations. The new 800 gig 7060 DX5 and 7060 PX5 both provide 32 ports of 800 gig with a choice of QSFP or OSFP optics and cables. Each 800 gig port is capable of running as 8x100 gig or 2 ports of 400 gig in a single RU and a 40% saving of power. We are also adding a new 32 port 7060 X5 400 gig system that offers 20% lower power consumption compared to existing systems, and it enhances features for high network radix AI clusters. The new 7060 X5 systems expand the choices with higher speeds and prepare the way for the next generation of 800 gig leaf and spine networks. Thank you.